Hello students, welcome back to class. This is class 8th, chapter 15, Introduction to Graph. Last 4 questions we have discussed in last video. Today we will discuss question number 5. Let us see what is question number 5. The number of days a hillside city received snow in different years 2003, 2004 up to 2006, and number of days 8, 10, 5, 12. Means this is a record of a city where that city hillside city received snowfall in 2003 8 days, in 2004 10 days, and in 2005 5 days, and in 2006 12 days. So let us plot this information on graph. Let us see, there are two axes, x-axis and y-axis. This I will consider y-axis and this is x-axis. Now, years and days, we have to check out which one is dependent variable and which one is independent variable. These number of days are depending on this year. In 2003, 8 number of days are there in which that city received snowfall. So this is independent and this is dependent. This days are depending on years. So independent I will take on x-axis and dependent variable I will consider on y-axis. So years I will consider on x-axis, years. These are independent variable. And number of days, these are number of days on y-axis. Now 2003, 4, 5, 6 and 7 till 6. Now consider, this is intersection point of this y-axis and x-axis. Now say this is 0. It is starting from 2003, 2004 and 5. One year difference is there. So from 0 to 2000, you will write 1. This is 2001. Next 2002, next 2003, and next one 2004, and next one is 2000. Otherwise these are not visible, so you can okay, let us draw one kink. This is one kink, means in between these are 2001, 2002, these all interval is showing but we are not denoting. Now this is 2003 and consider it is 2004, this is 2005 and it is 2006. In 2003 number of days are 8, 10, 5 and 12. So let us choose a suitable scale for this on y-axis. So you can consider 5 difference. So consider till there to there it is 5, then 10, then 15, then 20, till 20 we need, till 12, and next also you can consider 25. Now in 2003 number of days are 8. This is 2003. Let us find out scale. This 1 unit is equals to, on y-axis 1 unit equals to these are 10, 1, 2, 3. Divisions are 5 in between. So there to there are 10 divisions. 1 unit is equals to 10 divisions. So now write 8 days. 10 on y-axis, 1 unit means 1 unit is equals to 5 number of days. You will write 1 unit is equals to 5 days. And this 1 unit contain 10 divisions. These are 5 days. Means 1 day will be 10 by 5. That is 2. One division we have to find out. Division. One unit is equals to 5 days, and this 1 unit contain 10 divisions. 10 divisions is equals to 5 days. So one division we need to find out. To choose exact scale, one division will be 5 by 10. That is 0.5 day. Means this one line will represent 0.5. Now in 2003, this is 2003, number of days is 8. Number of days are 8. Find out where it will be 8. This is 5, and next will be 6. It is 0.5, then it will be 2 divisions will make 1. 6, then 7, then this will be 8. So in 2003, you will see, you will get this point there. Number of days are 8. Similarly, in 2004, number of days are 10. This is 2004 and number of days are 10. So 24, 2004, and corresponding to this is 10 days. So your point will be at this point. Now in 2005, this is 2005 and number of days are 5. And in 2006, number of days are 12. In 2006, number of days are 12. This is 10, then it will be 11, and then it will be 12. So at this point, this is 12. Now for this we have to draw linear graph, line graph. Now you can join these points. Start from it 0. This is graph for this given information. Hope you understood. First of all, we need to clarify on which axis we will take dependent variable. Always we are taking dependent variable on y-axis and independent variable on x-axis. So you will find out which one variable, which one quantity is depending on which one. Second thing, you will find out, you will choose suitable scale on x-axis and y-axis. Then you will define that scale on y-axis. How you consider 1 unit. This 1 unit I considered equals to 5 days. This 1 unit contain 10 divisions. So these 10 divisions will be 5 days. So I can find out 1 division. 1 division will be 0.5 day. So according to given information, now you can plot your graph easily. What is second part of this question number 5? Population in thousands of men and women in a village in different years. So we need to draw graph for this. How we can draw this graph for this? This is line graph. These are years 2003, 4, 5, 6 and 7. Number of men, number of women are given to you. For these years, corresponding to informations are given to us. So we need to plot 2 graph for this. Let us draw for men. In 2003, population of men were 12,000. In 2004, population was 12.5 thousand. In 2005, population was 13,000. In 2006, population was 13.2 thousand. And in 2007, population was 13.5 thousand. Okay. Let us choose scale on x-axis and y-axis. These number of men are depending on year. Means in 2003, number of men were 12,000. In 2004, number of men were 12.5 thousand. So these number of men are depending on year. So I will consider this is independent variable and this is dependent variable. Independent variable I will consider on x-axis. This is x-axis. I will write their years, and on this y-axis, this is y-axis, I will write number of men on y-axis. Let us choose one scale on y-axis and on x-axis. First of all, see 2003, 4, 5, 6 and 7. So I can consider there, this is 0, and one kink I will write in between, one kink, one jagged line I will show, because 2001 to 2000, 2001, 2002, these years I will not show on y-axis. I will start from 2003. This is 2003, 2004, 2005, 2006, and there 2007. Now see, number of men's 12, 12.5, 13, 13.2 and 13.5. So I can take difference of 1 in between. So from there to there I will show one jagged line, and then I will write from there, it's 10, then 11, then 12, then 13, and then 14, and then 15. This jagged line is showing that in between all intervals are present, but we are not showing them. Now in 2003, number of men are 12. Let us define scale on y-axis. How I considered this, 1 unit is equals to 1 unit equals to 1 man. 1 unit is equals to 1 man. And this 1 unit is equals to 1 man, like 10, 11, 12, 13, 14, 15. These 10 divisions are present in 1 unit. That is 10 divisions. 10 divisions is equals to 1 man. Then 1 division will be, 1 division is 1 by 10. That is 0.1 man. Means one line will show 0.1 man. This is in number of men in thousands. And on x-axis, this clearly we have taken this year, 1 unit is equals to 1 year. Now see, in 2003 there are number of men are 12. In 2003 number of men are 12. See, this is 10.1, 10.2, 10.3, 10.4, 10.5, 10.6, 10.7, 10.8 and 10.9. So these are tens. So in between, in 2003 there are 12. These are 12. Number of men are 12. So in 2003 you will see there are 12 men. Now in 2004, 12.5. In 2004 there are 12.5. So it will be exactly in between. So there it will be, this point will locate on 2004 there, and it is 12.5. And in 2005, number of men are 13. So number of men are 13 in 2005. So your point will lie here. And in 2006, 13.2. In 2006 it is 13.2. So it is exact 13, 13.1, 13.2, means on second line. This is 13.2. And in 2007, 13.5. In 2007, 13.5. So it will be exactly in between. So this linear graph is showing information in distorted form. It will show continuous change over time. So you can see this is location of these points on your graph. Now join these points with the line. This is your graph for number of mans in different years. Number of mans in different years. Hope you have understood this question. Again, let us see. First of all, you will define scale on y-axis and x-axis. This scale is important to define so that you can locate exactly these decimal number on your graph. You can exactly find out, you can get exact location on this graph. So after that, you have to join these all dots, these points with the line, then you will get linear graph or line graph. So second part you can try yourself. Question number 6. What is question number 6? A courier person cycles from a town to a neighboring suburban area to deliver a parcel to a merchant. His distance from the town at different time is shown by the following graph. What information this graph is depicting? This graph is showing that a courier person cycles from a town to a neighboring suburban area to deliver parcel. His distance from the town at different time is shown by this. Means one a courier person is there who is cycles from one town to suburban area to deliver parcel. Now, what is the scale taken for the time axis? This is time axis. 1 unit is equals to 1 hour. We need to tell what is a scale chosen on time axis. This is time axis. This is 1 unit, and 1 unit contain this 8 a.m. to 9, 9 to 10, 10 to 11, 11 to 12. So 1 unit is equals to 1 hour. On, you will write first part, A part. What is the scale taken for the time axis? On time axis, 1 unit is equals to 1 hour. This is scale chosen on x-axis for time. For time, the scale is chosen. 1 unit is equals to 1 hour. What is B part? How much time did the person take for the travel? How much time did the person? We need to tell time. How much time did the person take from for the travel? He started his journey from there and till there he traveled. Means he traveled up to 11:30. It is exactly in between, so it will be 11:30. How much time? Let us count this time. 1, 2, 3.5. 3.5 hour. That person 3:30 hour. How much time did the person take for the travel? He traveled from this point to there. Total distance traveled by courier person is this one, and he started from 8 a.m. and he stopped his journey at 11:30 a.m. So this total time is 3.5 hours. 3.5 hours. So this will be answer of B part. How far is the place of the merchant from the town? How far is the place of the merchant from the town? How far it was? From there to there he traveled, and it is of 20 kilometer. This distance is in kilometer. How far is the place of the merchant from the town was 22 kilometer. Place was 22 kilometer far away from his house. Did the person stop on his way? Explain. Let us see. Any linearity in our graph means constant thing. We want to find out. At this point, at 10 a.m. from there to there, he stopped. This graph is showing there is no movement, means there is no increase or decrease in this graph. It is constant from 10 to 10:30. This graph is constant. It's mean he stopped during this time. Did the person stop on his way? Explain. Yes, he stopped on his way between 10 a.m. to 10 a.m. to 10:30 a.m. He stopped in his way. Yes, he stopped in his way at 10 a.m. to 10:30 a.m. and at distance 16 kilometer. When he traveled 16-kilometer distance, after traveling that distance, he stopped for some time. By graph, there is no movement, there is no up and down in this graph. It is exact constant. So it's mean he is staying here. Next question is, during which period did he ride fastest? In which period? Let us see where is maximum peak, where is rapid increase in our graph, that we are going to find out. You can see from there to there, and then this one curve, and then this, and then this. I think maximum rapid is at this point 8 a.m. to 9 a.m. means he traveled. During which period did he ride fastest? During 8 a.m. to 9 a.m. Which one period? 8 a.m. to 9 a.m. he ride fastest. Its answer will be, E part answer will be during 8 a.m. to 9 a.m. he traveled fastest. He traveled fastest. Question number 6 is completed. Question number 7. Let us see, can there be a time temperature graph as shown? Justify your answer. Means we need to tell which one graph is possible. These two parts are given to us, two more parts. Then we need to tell which one graph is possible and which one is not possible. So let us see, read out first graph. This is time and this is temperature. Time temperature graph is given to us and its curve. When time is increasing, then in proportional temperature is also increasing. Time is increasing and corresponding there we can see increase in temperature also. So such possibility is there. If along with the time, temperature can also increase. Like in summer, we can take example of summer, 8 a.m., 9 a.m., 10, 11, then sun rays are more stronger comparatively in morning, comparatively high in noon time as in morning. So means time is increasing, then temperature is also increasing. Time is increasing, then temperature is also increasing. So such type of possibility is there. Yes, this graph can exist. What is second part? Time and temperature. As time is increasing, first from its peak maximum to temperature is decreasing. It can be possible when time is increasing and then corresponding temperature is decreasing. So such possibility is also possible. So this graph can exist. Yes, there is a time temperature graph which can show this possibility. So both graph exist. Now let us see next part. What is third part? This is time and temperature, and this also time and temperature. You can see, read out these graph. If visible, you can see there is a straight line, and in this graph you will see this one. So temperature and time. You will see when time is increasing and at particular time temperature is keep going increase. Suppose 8 a.m. now time is 8 a.m. and at this same time temperature is increasing. Temperature is increasing. How it can be possible? On same time temperature can't be increased. If there will be change in temperature, change in this time, then we can see corresponding change in temperature. So at fixed time, this possibility we can't see, that our time is fixed and corresponding to this our temperature is going to be increase and increase. So this is not possible. So such possibility doesn't exist. Let us see next part. As time is increasing, then at that point temperature is constant. Sometimes we can see at 8 a.m., 9 a.m., 10 a.m. temperature is suppose 10 degrees Celsius, or in different area you can see temperature is 30 degrees Celsius or minus 4 degrees Celsius. So this can be possible when time is increasing, but the temperature is constant. Temperature is constant. Such possibility is exist, means this graph is existing, but this graph is not existing. Our chapter 15 is completed. In next video, we will discuss next chapter. Thank you for watching.